Dear students, Assalamu alaikum. Yesterday we discussed about the definition of physical quantities and its types. Then we discussed about measurement and need for measurement of physical quantity. And I also told you about a unit, which is also known as the physical standard. And in this lecture, we are going to study the unit and its characteristics. Definition of fundamental units. Number 3, dimensionless or supplementary units. Number 4, SI units and advantage of SI units. As I told you yesterday, the definition of unit, it is defined as the selected magnitude of a physical quantity in terms of which other magnitudes of same quantity may be expressed as multiples. For example, the length of a wall is 10 meter, then the length is equal to 10 times the length of a meter. Similarly, if the weight of a sack of rice is 20 kg, it means that the weight of sack of rice is 10 times the weight of kg. So to measure the magnitude of a physical quantity Q, we must know two things: physical standard or unit U, number two, numeric N, which implies that Q is equal to NU. As I already told you, for example, if the physical quantity is length L is equal to 20 meter, then 20 is the numeric and meter is the unit. Similarly, the weight of sack of rice is 20 kg, 20 is the numeric and kg is the unit. In general, if a physical quantity Q is measured in two systems of units, say U1 and U2, having numerical values N1 and N2 respectively, then Q is equal to N1 U1, say in MKS system, and Q is equal to N2 U2, say in CGS system. For example, if length is equal to 10 meter in MKS system, then length is equal to 1000 centimeters in CGS system. So in first case, N1 is 10, and in the second case, N2 is 1000. In first case, U1 is meter, and in the second case, U2 is centimeter. So from equation first and second, as you can see, we get N1 N1 U1 is equal to N2 U2, which implies that U1 divided by U2 is equal to N2 divided by N1. This expression U1 by U2 is called conversion factor or change ratio for conversion from one unit to another, say from MKS to CGS. If U is smaller, as I told you, if U is smaller, then N will be greater and vice versa. For example, in first case, length is equal to 10 meter, N1 is 10, and U1 is meter, which is equal to 1000 centimeter. In that case, N2 is 1000, which is greater than N1, and U2 is centimeter, which is smaller than meter. Now, characteristics of a unit. The unit must be reproducible. For example, as I told you yesterday, if the unit vanishes, then we must be able to reproduce it. We will discuss it in the later lecture, how we can reproduce it if it vanishes. It must be well defined. It means everyone, it must be intentionally well defined. Everyone should be able to understand its definition. It must be imperishable. It must not perish. It must be of suitable size, means as you have seen meter, as you have seen kg, they are of suitable size. If they would have not have been of greater size, then it would have not been able for us to measure the length of a rope. For example, if the size of the meter would have been uh, as large as the length of a tree, then it would have not been able for us to measure the length of a wall. So it must be of suitable size. Similarly, if the kg would have been of the size of the sack of a rice, then it would have not been able for us to measure the weight of an apple. So these units must be of suitable size. Similarly, it must be accepted internationally. For example, if one country accepts it and the other denies it, then uh, yes, it will not be. We will not be able to measure the weight of physical quantity in one region or the other. So it must be accepted internationally. It must be comparable with other similar units. It must not change with physical conditions like temperature, pressure. For example, if the length of the meter increases with increase in temperature, then the length of room will we will not get the correct length of the room or correct weight of a sack of rice. So it must not change with physical conditions like temperature, pressure, etc. Now let us define these fundamental quantities. As I told you in the previous lecture, that there are seven fundamental quantities. How we can measure it? How the measurement of these fundamental units have been derived. For example, we know that the meter is the fundamental unit of length, and it is equal to 1650763.73 wavelengths in vacuum of the radiation corresponding to the transition between the levels 2p10 and 5d5 krypton 86 atom. For example, we have to take krypton 86 atoms and we have to take two levels of it, 2p10 and 5d10. And if an electron jumps from 2p10 to 5d5 or from 5d5 to 2p10, it will emit radiation, it will emit light, uh, and then we have to calculate the wavelength of the radiation when it jumps from level 2p10 to 5d5, and we have to count 1650763.73 wavelengths, and that will be equal to 1 meter. So as I already told you that these fundamental units must be imperishable. If they perish, if they vanish from uh, this earth, then we will be able, because atoms cannot vanish. If atoms vanish, then we will not be able to. So atoms cannot vanish. We have a krypton atom. It will exist as long as this universe exists, as this world exists. So krypton is very much there. We can take the two levels, 2p10 and 5d5. Then we can see the transition of an electron from one level to another, and we can calculate the wave length and take as much as wavelengths we need to get this meter. So 1 meter is equal to 165076373 wavelengths. When an electron jumps, when an electron in a krypton jumps from 2p10 to 5d5. Similarly, kilogram. Kilogram is the fundamental unit of mass and is equal to the mass of the international prototype platinum iridium cylinder of diameter equal to its length, kept in IBWM. That is International Bureau of Weights and Measures, which is at Sierre, France. So this is still there, this kilogram. Its height is equal to its diameter, and it is made up of platinum iridium cylinder, which is an alloy. Suppose if we have this kg and we feel that its weight is not equal to exactly equal to 1 kg, then we can take it to this IBWM and find it out whether its weight is equal to the international prototype platinum iridium cylinder. So it has been preserved there. Similarly, second is the fundamental unit of time and is equal to the duration of 91926317770 periods of the radiation corresponding to the transition between two hyperfile lines of the ground state of cesium 133. So in case of meter, we have taken krypton atom, and in case of the second, we take cesium. And in cesium, we take two hyperfile lines. What are hyperfile lines? Hyperfile lines are when this cesium atom is subjected to a strong magnetic field. Each line splits into two or more than two lines, and those lines are called hyperfile lines. So we have to take the hyperfile line of the ground state. Suppose ground state is K shell. When this KLMN, when this cesium atom is subject to strong magnetic field, K shell will split into two or more than two hyperfile lines, and the electron will jump from one hyperfile line to another, and we have to calculate it. Is again, we have, in case of it, we calculate wavelength. In this case, we will calculate time period, and these we will take 919263177 time periods, which will be then equal to 1 second. Means this atom will make 919663177 transitions in 1 second. Similarly, ampere. Ampere is the fundamental unit of electric current. It is defined as the constant current which, when flows in two infinitely long parallel conductors of negligible cross section, placed in vacuum at a distance of 1 meter from each other, produces between the two conductors a force of 2 into 10 raised to minus 7 Newton per meter length. Which means that you have to take two infinitely long straight wires of negligible cross section. It means they must be very, very thin, and you have to keep them at a constant distance from each other. And when a current flows between these two wires, same current in both the wires, and if they produce a force of 2 into 10 raised to minus 7 Newton for them, they will attract or repel, depends upon the direction of the current. If the current is in the same direction, they will repel, and if it is in opposite direction, they will attract. And when they this force of attraction or repulsion, it must be equal to 2 into 10 minus 7 Newton per meter length. Then we will say that the current in the two wires, in both the wires, is equal to 1 ampere. Similarly, Kelvin is the fundamental unit of this thermodynamic temperature and is equal to the fraction 1 by 273.16 of the thermodynamic temperature of triple point of water. So what is triple point of water? Triple point of water is the temperature at which water coexists in solid, liquid, and gas state. Where you cannot, it is the temperature at which you cannot say whether water is in solid or in liquid or in gas state. So that point is called triple point of water. It is perhaps nearly 0.4 Kelvin. Then there is another unit, fundamental unit, that is candela. Candela is the fundamental unit of this luminous intensity. It is defined as the luminous intensity in the perpendicular direction of a surface of 1 by u square meters of a black body at the temperature of freezing platinum 2046 Kelvin under a pressure of 101325 Newton per meter square. What does it mean? We have to take a black body and we have to put a radiation, means light on it, electromagnetic radiation on it at perpendicular direction, and we have to take 1 by 6 double zero 000 square meters of that black body and see how much light it absorbs or then emits. That will be equal to 1 candela. So in generally in Kashmiri we say that when we purchase a bulb from the market, we say how much candle lamp means. If it is 10 candle, means its light, it will emit light whose intensity will be equal to 10 candles. So one candle is nearly equal to 0.98 that of luminous intensity of a candle. Then there is mole. Mole is the fundamental unit of amount of substance, and it is defined as the amount of substance of a system which contains as many elementary entities as there are atoms in 0.012 kg of carbon atoms. So we have to take the weight of carbon atoms equal to 0.012 kg and then calculate how many atoms are there present in it. If suppose that if there are 1000 atoms present in 0.012 kg, then mole is equal to 1000. Then mole that number of atoms will be equal to 1 mole. Now there are, in addition to these 7 fundamental units, there are 2 supplementary units. One is radian and the other is centiradian. Radian is the fundamental unit of this angle, plane angle, uh, and is equal to the angle subtended at the center of the circle by an arc arc whose length is equal to its radius. For example, you have to take arc 10 centimeter of the circle whose radius is 10 centimeter. So if the radius is equal to the length of the arc, then the angle subtended at the center of the circle will be 1 radian. Then there is centiradian. Centiradian is the fundamental unit of solid angle. In that case, you can take a sphere, and the angle subtended at the center of the sphere by the surface whose area the surface whose area is equal to the radius of the sphere, then that angle is equal to 1 radian. Now after this we will discuss system of units. What is system of units? A complete set of units, both fundamental and derived, for all kinds of physical quantities is called a system of units. Each system is named in terms of fundamental units. Now, there are 3 systems of fundamental units. FPS. F stands for foot, P stands for pound, and S stands for second. So in this case, F foot is the fundamental unit of length, pound is the fundamental unit of mass, and second is the fundamental unit of time. Now there is another system of units. This system is also known as British engineering system, and if you go to British, you will get everything in pounds. Uh, in case of this mass, and in case of length, you will get everything in foot, 10 feet, 30 feet of length, 70 feet of length. Similarly, 10 pounds, 20 pounds, 30 pounds. This system is still operating in British FPS system. Then there is another system, CGS system. In C stands for centimeter, G stands for gram, and S stands for second. So in CGS system, centimeter is the fundamental unit of length, gram is the fundamental unit of mass, and second is the fundamental unit of time. This system is also known as Gaussian French system. It is very much operated in France. So that is why it is also known as Gaussian French system of units. Then there is MKS system. M stands for meter, K stands for kilogram, and S stands for second. It is also known as metric or decimal system of units. In this system, meter is the fundamental unit of length, kilogram is the fundamental unit of mass, and second is the fundamental unit of time. Now, SI system of units. The name SI is an abbreviation of List System International de Units, which is French equivalent, means in French, uh, it, this List System International de Units, it is in French language, and which is in English means System of Units. And this system was introduced in 1960. This system of units is essentially a modification over MKS system, means it includes complete set of MKS systems. In addition to that, it also gives us units for other derived as well as supplement units. Now, in this system of units, the unit of length is kilogram, the unit of the unit of length is meter, the unit of mass is kilogram, the unit of time is second, electric current it is ampere, in thermodynamic temperature it is candela, thermodynamic temperature it is Kelvin, and luminous intensity it is candela, and amount of substance it is mole, plane angle it is radian, and for solid angle it is city radian. In addition to fundamental and supplementary units, there are large number of derived units on this system of, for example, for force, the unit of force is Newton, for work, energy, the unit is joule, for power, watt. Similarly, electric charge, there is coulomb, electric potential, there is volt, for capacitance of a capacitor, it is farad. So these units are in only in SI system. These units are not in MPS or CGS or FPS system. That's why this is called a modified. Means it includes MPS system. In addition to MPS system, it has uh, several other units for other physical quantities, derived physical quantities. Now, advantages of this SI unit. What is the advantage of this SI unit? SI unit is rational because it absorbs the rationalized MKS system. SI unit is coherent because it is based on certain set of fundamental units from which all derived units are obtained by simple multiplication or division without introducing a numerical factor. SI unit is comprehensible because it uses only 7 fundamental and 2 supplementary units to cover all the fields of secondary uh, science and engineering. The SI units are easily reproducible. The SI units are imperishable. This is all for today. See you tomorrow.